So just as a reminder, before we get going, this is a continuation of the three-part SQL talk for our ARC series, our Advanced Research Computing talks, which are now posted. So they're posted on our training.sharknet.ca location if you want to see the previous ones. And this is a continuation of the Introduction to SQL. And today, the two main points I want to focus on are going to be constraints and joins. But before we really talk about constraints and joins, I want to do a quick little talk about data relationships. Now, this is a parsed down version of what I was originally going to talk about. This is just a talk about how we put our tables together and how we decide what does and does not go in them. This will be just a brief overview. And these are, so basically the relationship on the data in your tables will be it. So what we have here is what we will call a monolithic table. And a monolithic table, also known as a denormalized table, is a single table design in a database structure where all the data is stored in a single table. And there's little or no attempt to normalize the data by breaking it into smaller related tables. While there may be specific cases where a monolithic table is appropriate, generally speaking, this has several disadvantages that makes it less desirable in most database design scenarios. First and foremost is the data redundancy. And in this table, so if you take a look here, you have the course English 1000 is repeated 3 times, where the date and the instructor are identical. So this is redundancy in the data that's going to take up space and can cause inconsistencies. So if I change the date here and I don't change the date here, you're going to get a problem that they don't match. And that makes it hard to maintain your data integrity and limits the scalability of your tables. It's hard to grow these tables to add more values, as over time it just becomes unmanageable. Your queries become complex and your tables lacks flexibility. And in short, it's a maintenance nightmare. So that's why you would normalize your table. So normalization means breaking your tables up in order to reduce data redundancy. So reduce the amount of data that's repeated. And there's a series of rules for normalization that you can follow if you ever want to look into it, and they're called normal forms. But we're just going to break it up kind of and have a look at what's going on. So we break up that monolithic table into 4 different tables here. And this makes it easier to manage. We're going to add and remove columns as we go as well, which is a lot easier with these smaller tables. So this is called a normalized database schema, in that the data redundancies have been removed. So what we've done is we've identified what we want for the tables by splitting up. So we want a students table. So we're talking about an education schema here. That's what was back here, was instructors and their courses. And we're talking just a kind of a toy schema for education. Of course, in the real world, this would be much larger, many more tables, many more columns, but this is good for demonstration purposes. So we've broken it down into 4 tables. We've got students table with the UID, so the unique identifier. PK means primary key, and that's identical to the instructors table. Now, while that may seem like duplication, they do have the same columns and the same style of data, but they have different purposes. So we broke them into 2 different tables. Over here, you have courses, and you have, again, you have a unique identifier as a primary key, name of the course, the date, and you've got a foreign key pointing to the instructor primary key. And that's because, so what's going to happen is instructors have courses and they need to be related. And attendance is student to course. So you have the student foreign key and the course's foreign key. So the primary key is your reference table, and then some additional data on the attendance table. And these are the relationships between data that really is what relational databases are all about. So we've designed the database structure by deciding what tables they'll need and how they'll be structured. And this is normalized again. It's organized in such a way as to reduce data redundancy and improve data integrity. And what we've got here is, this is very similar, a lot of people are going to call an entity relation diagram. And the entities are your tables, and then the relations are how the keys relate to each other. So data relationships are a fundamental concept used to link data stored in different tables. These relationships are essential for organizing and retrieving your data effectively. And there are several, so we've got 4 different data relationships in SQL. You got the one-to-one relationship, which occurs when each row in a table is linked to no more than one row in another table, and vice versa. This is an uncommon relationship, and usually means that the 2 tables could be combined into one. A one-to-many relationship, this is your most common type of relationship. In this scenario, a row in table A can be related to many rows in table B. And in the many-to-many relationship, it means that any number of rows in table A can be related to any number of rows in table B. And then there's a self-referencing relationship. And that means that we have a foreign key reference in a table that refers to a row in the same table. And these relationships between different tables are established through the use of keys. A primary key, which can be a single column or a combination of columns, we've covered in a previous video, is utilized to uniquely identify the row within the table. And that ensures that every record is distinct and retrievable. And the foreign key will reference that primary key, and it's considered a constraint. So this is an example of a one-to-one relationship. Now, what it's saying is there are many instructors, but each instructor, oh, sorry, this is a one-to-many relationship, my mistake. Each course has exactly one instructor. So for every course, there's one instructor, but one instructor can have many courses. And so a one-to-many relationship typically involves 2 main entities or 2 tables. So each instructor is identified by a primary key, and each course is represented by the foreign key, which references the primary key. And using these keys is a way of establishing the relationship and keeps things well structured. Now, this is a one-to-one. We've added down here an advisor ID as a foreign key. And this is kind of artificial because an instructor typically wouldn't advise exactly one student, but it's rather difficult to find examples for one-to-one relationships on separate tables. As I said before, these are much more often combined into one table. So let's just assume that instructors can have a student advisor. Student can have an instructor as an advisor, but they can only have one advisor, and instructors will only advise one student. And that would be an example of a one-to-one relationship. This here is this is a many-to-many relationship. So in the one-to-many relationship, you use the foreign key to primary key relation, which we've covered. It's fairly simple structure. In a many-to-many relationship, you need any number of students can have any number of courses, and each course can have many students. And the best way to show this relationship is by using a joining table, also known as a junction table or an associative entity. These are all the words, different words for the same thing. And this table is necessary because the relational databases can't directly handle the complexity of a many-to-many relationship within a single table. This joining creates a bridge between 2 tables that have a many-to-many relationship. So you start with 2 parent tables. The parent tables in this case are students and courses, and each of these tables will have their own primary key, and we're using a unique identifier for the primary key. And then you have a third table, which is known as the joining table. And you create this table, it must have at least 2 fields. So the foreign key to the students and the foreign key to the courses are mandatory for a joining table. You can also include a primary key if you need to reference it from outside. It's not required for the joining table. And any information. So if a student is in a course, they might have a grade or an attendance or something like that. And that is data related to the join. So that would go into the joining table because it makes no sense to put the grade in the students table because they have many courses. And it makes no sense to put in the courses table because they have many students. So the joining table gets it any information that is related to the joining of those two tables is put in together. And those are the additional attributes for that table. Now, there's one last relationship, and that is the self-referential relationship. Now, the way we looked at it before, there were no self-referential relationships in the table, so we're going to invent one here. Let's say an instructor has a manager, a supervisor who watches over them. They are also instructors. So a self-referential relationship is established within this instructor table through this manager ID column, which is also a foreign key. So it'll have a foreign key constraint on it. And this creates a hierarchical model or a hierarchical relationship among instructors, where one instructor can be manager to other instructors or even to themselves. So they could have a manager ID that points to their own. And that's what this relationship here is showing, is that it's a self-referential relationship. So the use cases, so such a structure is useful for modeling real world scenarios where you need to keep track of a certain hierarchy or a graph. So from one to the other, where all the nodes of the graph contain the same kind of information, you need to add some sort of relation between them, and that's the self-referential relation. Now, if you're handling, so say you've got this hierarchical managers, if you've got a top level manager or the department head, so to speak, they typically wouldn't have a manager above them. So you can set this to what you like. You can set it to null if you want, or if you don't want nulls in your table, you can alternately set that manager ID to be their own ID so that it kind of represents themselves. So in the end, our normalized table looks kind of like this. Now that we've described the tables, we would have to create them and so on. But you can see the advantage between this and the monolithic non-normalized table in that it was easy to add columns to this. So we wanted to add a column, a manager ID or an advisor ID, without having to worry about things that are unrelated to it. So when we add the manager ID to the instructors table, the students table doesn't care about that manager ID. The courses don't need to know. So it's easy to manipulate a normalized database schema, whereas a non-normalized one is more appropriate for presenting data. So if you wanted to show data to someone, you would create more of a monolithic table, but you're not going to update or change things there. So that was the abridged data representation. And now we're going to talk about constraints. So what is a constraint? In SQL, a constraint is a rule that limits the type of data you can store in a table. So these constraints ensure that your data conforms to rules that you set for it, reducing potential future conflicts. Several SQL constraints are available. We've already covered a few, and in this section, I'm going to introduce the rest of them to you. So what we've already seen, so primary key is actually a constraint, and it's not a constraint on its own. It's kind of it's an amalgamation of constraints, and that is not null and unique. That means the primary key, we know, must contain a value, and it must contain a value that isn't anywhere else in the table. So that's known as not null constraint and unique. The foreign key is also, so you've heard me refer to it as the foreign key constraint. What that means is any value in that column must be referenced in another table or the column of another table. It must exist in order to keep the constraint valid. And we've also previously seen auto increment, which doesn't seem like a constraint. But what auto increment does is says, if a null value is included, add a new value that's higher than our previous value. And we're not going to cover those now. We've already covered them verbatim in the past. So the not null constraint ensures that every column must have a value in every row. You can't have a null value in the column. And that's quite self-descriptive in this case. So if we take a look at our instructors table, if we described the instructors table that we saw in our schema a minute ago, you remember from the describe command that there's fields and types. That's very familiar. And we've kind of glazed over a lot of this. We're aware of auto increment. And this is a primary key. And what the primary key is automatically says no here. But what is going on in this value? Well, this column tells you whether or not that, sorry, whether or not this column, I guess, is permitted to have a null value. So because it's a primary key, it's not, but all the other ones by default are permitted null values. And you almost never want that. Most of the time, you don't want null values in your table, because null, specifically what null means is the value is not set. It's a placeholder for data that does not exist in a table's column. Now, null is different from zero or your empty string, in that zero and empty strings are values. And if you put those into the table, they represent something specific. Null signifies the absence of any value, whether it's numeric, text, date, or otherwise. And it means you haven't set the value there yet. So let's take a look. This would be the create table syntax for our instructors table. We have a UID, integer is an integer primary key auto increment. That's all familiar. Now, first name, last name, email. And these are all pulled from our data schema earlier that we looked at. And we want to set this with everyone has a first name or a last name, or we want to make sure that everyone has a first name or a last name. So what we're going to do is we're going to add the not null clause to the column declaration. And what that will do is it will, when you enter a value or you input a value into your table, it's going to throw an error if you put a null into that column. Now, I'd like to point out, as we saw from the description here, there's also default values. So that means that the default for even the primary key is null. So if you enter an empty value, it's going to put a null in there, and that's also going to be an error, which we're going to see momentarily. So let's just do a quick little demonstration. So this is the tables. We're going to work with the instructors and courses tables from the schema earlier. And this is the workbench we introduced before. And I'm just going to use this in order to reset my tables and clear them up. So there we go. So now we got some instructor tables, a courses table, which references the instructor table. And we've inserted some values into here. Now, if you take a close look at this, we will take a look at the values in here. So show tables, select star from courses. Note that there are null values in there and in the instructors as well. There are also instructors that don't have courses. So these UIDs reference up to here. 1, there's no 2, there's no 5, there's no 6. You can see it. Now that's going to be important later on. I'm just bringing that forward now. So let's play around with not null for a second. So if we insert into instructors, now we'll specify, we're only going to insert the first name, values, Bill. That's perfectly valid. To not include an email, to not include a last name. And if we take a look at select star from instructors, you will note that it inserted it, created a new primary key, and just put in null where the last name and email are. And the reason it's putting in the null is because that's the default value, or the default value would be the best way to describe it. So if we describe instructors, you'll see under here is the default. So that's the value it's going to put in if you don't specify it. And there's another thing you can do. You can insert, and this is something you probably don't ever really want to do, into instructors, instructors. And we're not going to specify any column names. We're just going to say an empty values clause here. And what that is, it means insert a null set into the instructors table. And that's perfectly fine. So if we select star from instructors now, a full null set has been entered. And that's basically useless data. And you can keep doing that as much as you want into instructors. We can just enter all the null sets you want. And like, there's no differentiating factor there. It's not something you're going to want to do. So let's go over to the workbench, and we're going to add the not null clause to the first name and last name. Now, typically you would probably add it to the email as well, but just for our demonstration, we're just going to leave that so you can have an email as a null, but you must have a first and last name. I'll reset those tables. Now remember that when I do that, it actually deletes the previous table, so we removed the data that I just entered. We'll describe structures, and you'll notice now that it says null for those values. However, the default is still null. So if we insert into constructors, we try to insert the null set again, we're going to get an error. And the reason for that is you have to specify a value for anything that says not null, because the default's no longer valid. So we will insert first name. This is still going to have an error because it says last name. So it'll tell you the first field it's come across that is invalid. Won't tell you all the ones that are invalid. So we'll fix that. We'll go last name, Bill Williams. And there we go. Select star from instructors. And now it's inserted, it still inserts the null under email because we didn't set the null clause, but now the first name and last name have to have values when we insert. Now we can also alter table. If you want to, if you've got something, say we've decided after the fact that we want to make email not null, we can alter table. Alter table instructors will modify the column. Email, so it's varchar, so we still have to put the type there. And we'll add the not null clause, semicolon, not colon. And we're going to get an error. And the reason we get an error is if you modify a column that will constrain a value such as not null, so it says you can't have a null in there, but there is already a null, so we've already got a null in the email, you can't modify this column to discount a value that's already in there. So you have to get rid of all of the null values from the table before you change it. So what that means is delete from instructors where email is null. Now null is not a value, so we can't say equals null. This is not, we can't say this. That's not valid. Oh, apparently it does it. It's supposed to be is null. So when we say equals null, it's not an error, but it does say 0 rows affected. No rows have been removed. You have to say is null in order to remove the row. And now if we select star from instructors, there's no null values in there. And now we can update the table to have not null on the email. If we describe instructors now, we'll see that we're no longer permitted null on the email. So a couple of little notes moving on from null values. So we saw that a null comparison is undefined. You have to use is null or not null. It won't throw an error. It will simply ignore the computation because all arithmetic operations involving null result in null. So if you null plus 3 is null. Null concat with a string is null. All logic operations using null are ignored. The null input is ignored. So you're going to get some weird behaviors in that, like true and null is true and false and null is false. Null is not anything. It's not a Boolean value. And there are aggregate functions in SQL, things like sum, average, count, and they won't include null values when you perform these operations. So there's a number of reasons you want to avoid null if you're expecting it to actually be a value. So if you're like to count all emails and one was null, it's not going to be the same as all the rows. So moving on, we're now going to talk about the next constraint, which is unique. The unique constraint ensures that all values within a column are distinct. It prevents duplicate entries in that specific column of the database. To do the unique clause, you'll add the unique keyword to the column declaration. It's the same as not null. Now you'll take a particular note here. We have deliberately left not null off the email. And that's because I'm going to demonstrate to you that a unique clause will fail if you put the same value in twice. Or sorry, like the constraint will be caught unless it's null, because null is not a value, unique doesn't apply to it. You can also alter the table instructors the same way as we did with the not null value by modifying the column and adding the unique clause to it. So let's go over to Workbench first. We are going to adjust our table to add unique. And that's all we need to do. We'll just reset our tables there. And we will describe structures. And now it's got now unique is considered a key. And that is because unique values can be indexed in such a way as to speed up the use of the database. It can still be null, however, and it's not actually a primary key, so it's a unique key, I suppose. So let's take a look at this. So if we add, for the sake of arguments, we are going to add a new column to our table. So first of all, let's actually, before we do that, let's select star from instructors. Now I'm going to show you what it does. So we're going to add another row. We're going to repeat an email. So if we insert into instructors, we want first name, last name, email, values, and we're going to use Mark Markerson. We're going to give him the same emails we gave someone else. We're just going to copy that email right there. Show you what happens. And you're going to get a duplicate entry error, and it's going to tell you the table and the column that you have it for. And of course, if we select that, so when you get this error, no insert took place. So no change has been made because you can't because email is unique, it's not valid. So the insert statement is not valid. And that's what a constraint basically is constrain your values that you can enter into the table. Now, as I pointed out before, we didn't set not null. So if we simply omit the email entirely, it'll be fine. And that's not because there was no null value in there already. If we want to add another one, Pamerson, and we're going to give her a null email as well. We're not going to set an email to it. It's perfectly fine. And that is because null values are not values, so they don't count against the unique constraint. The unique constraint says there are no repeated values. And null is not a real value. You should consider it a placeholder for nothing entered. Now we're going to alter the table. Then another way of adding values or adding, so we can alter table. We've seen modify column a lot. We're going to use add column, and it's the same as modify column, except instead of changing a column that's already there, it's going to add a new column. We're going to call this tenure, like years of service. How long has this prof or this instructor been working for us? We're going to add default, so we don't want null. We say if you haven't included a value, a default of 0 makes the most sense. Actually, I've moved on to default. My mistake. Let's go back. Sorry. Got my demonstration ahead of my slides. Next, we're doing default. As you may have guessed by I just put in a default value. And what is default? We've seen on the table that we have default null values when we enter a row and we exclude a value from it. Well, we can change that and we can use the default clause. The default clause defines the value for a column when no value is specified during insertion. So we can create the table as we have. So you saw, as we did with unique, Not null was there. I seem to have omitted it from this one. So in tenure, which is going to represent how many years of service, it makes no sense to have negative years of service or null years of service. We're going to put in 0 as a default value. We're going to alter the table and add the column instead of modify column to do it. Okay, now we've caught up our demonstration to our slides. So we are going to alter table instructors, add column tenure, default 0. I forgot to give tenure a type. Type is integer. There we go. So now if we describe instructors, we have another column in here, and that's tenure. And tenure is an integer. It can have a null value as it sits, has no keys, and it has a default of 0 instead of null. Now let's take a look at the values we've already added, sec star from instructors. When you add a table, when you add a column that doesn't already exist with a default value, all the rows or all the records we've added to the table already will have that default value inserted. So you can see we have tenure of 0 instead of null because that's what we set as the default. And now if we insert into instructors, we have to go first name, last name. We're not going to include email. Email can be null. We're not going to include tenure because tenure has as a default. Values, Bill Williams, perfectly valid. And what happens is, so Bill Williams gets the email, the default is null, and the default for tenure is 0, so it gets inserted. We're going to add another row, so just to show you the default values, the default is null. Alter table instructors again. And we're going to add a column called salary. So how much they make? Salary, it's an integer, but we're not going to set a default to it. And if we select star now from instructors, if you don't set a default to a new column, it'll set the value to null. So that's default values. If we modify the column salary now, so we've added the column, it has no default, and we are going to alter table instructors, modify column. Notice we're modifying the column, not adding the column this time, and we're going to add a default. So salary means an integer, and it's going to have a default of 0. No changes have been made, and if we describe the table, describe instructors, the default is 0, so it's in there. But if we select star from instructors, they're all still null. And the reason for that, if we modify the table to add a default value to a column that already exists, it's going to just use the values that are already there. So if you want it to use the default value, you would have to remove that column and add it in again, in which case you might lose data. So you just have to be careful about that when you modify columns. So our next is check, and check is our catch-all constraint. The check clause enforces tongue-tied there. Sorry, the check clause enforces specific condition on a column to ensure that all values of the column satisfy the specified condition. So this is very similar to unique and not null, except that you are going to specify what the Boolean equation is. So this is a catch-all constraint. It allows you to check for valid values beyond just not null and unique. And in this case, we have put the check on its own line down here. So these are column definitions. And then we have a check definition. This can go on its a line with the column definition, but it can also go separate. It's a bit clearer. So what is the keyword is check. And inside the parentheses here is a Boolean evaluation that will tell you whether or not it's true or false. Note if the check fails, the record doesn't get inserted into the table. We can also use something that, so we added column before, so alter table instructors, we can add check in tenure is greater than or equal to 0 in much the same way that we added columns, because you're basically just adding another line to your create table declaration. And we are going to go in there and let's add some checks. So first things first, before we do, I'm just going to reset this to, so we want to go default 0 from before. That's the same. We're not going to worry about salary. We're just going to reset our tables so that we're working with a nice clean table. Oh, I added default 0 to email. That's not right. We're going to go tenure, integer, default 0. Gonna run it. Oh, we got an error. What's our error? Probably the extra comma. It does not like extra commas. There we go. So we'll describe. And we can see we've got tenure, so everything's here is in our vanilla form. And we will select star. Oh, I cannot type instructors today. And everybody's got 0 tenure. Now, what we want to do is tenure can't be negative. Right now, we've got a default value of 0, but we can always, let's insert a new record, insert into instructors, a little first name, last name, we don't care about email, and tenure, values, Bill Williams again. And Bill Williams, you would normally add 5, right? So he's been there for 5 years. But say we add another one. You could actually add the same name twice, but we add Bill Williams number 2. We'll call him Billy Williams. And he has -5 tenure. That's completely valid the way it sits right now. And we don't want to allow that. So what we're going to do is we're going to alter the table. We're going to add a check to the table. We'll alter table, add check. And inside the parentheses is the Boolean rule. And the rule is going to be the name of the column, tenure, whatever your operation is. So we're going to say greater than or equal to 0. And now we have to be greater than or equal to 0. Now we've got a problem in that this record wouldn't pass the check. So when we alter the table to add a check in the same way as we alter the table to add a not null, any values within the table that are invalid will cause a failure to your alter table. So we have to delete that row. So we'll delete from instructors where tenure is less than 0. So we'll get rid of that row first. And now we will alter the table. Lost my alter table command. Oh, there it is. Alter table, add check, and then tenure is greater than or equal to 0. Oh, what have I got wrong? Oh, I always forget the table name when I do this. Alter table, instructors, add check. So now we are going to try and add the -5 guy again. So we're going to insert Billy Williams. Bill Williams, misappropriately named brother, with a -5 tenure. And that gives us an error. And that error is instructors underscore check underscore 1 is violated. And that is a weird sort of name. If we insert him with 5, it's completely okay. Now, if we describe instructors, you'll see no mention on here of the check value. There's no check constraint on here at all. There's no indication that we've done that. So we're going to use another command. It's going to go show create table. instructors, which is a different way of showing your table schema. And this is the create table command that we would use to recreate this table. And it's a little ugly because this is, as you'll notice, a table on its own with the table name and then the value. And we're going to just add, instead of a semicolon, \G, and this will print it out all as records. It just makes it a little bit more readable when you have these big values, because it's a really long string value in there. So that's the table is a column, and that value is instructors. Create table is the column, and that's the value. And if we take a look down here, we see our check that we added. That looks very familiar, but there's this thing right there, and it says constraint with that name that we saw, instructors check _1. And this is a bit of a segue into our next constraint. And that constraint is not so much a constraint in itself as much as the constraint keyword. And the constraint keyword allows you to name the constraint to something that makes sense to you. So down there, in the same way that you add the check line in its own row, you add the constraint line in its own row. The constraint keyword, this tells us we're creating a constraint, a named constraint. The name of the constraint, so we want to make sure that tenure is positive. We'll call it tenure positive. And check, so that's the constraint. The constraint we're putting in is check that tenure is greater than or equal to 0. So let's go and do that. We are going to put that in here, and we are going to go constraint. Let's name it constraint tenure positive. Check. Tenure is greater than or equal to 0. Make sure we got all that correct. Oh, I got it on the first try this time. So now, if we take a look at our table in the same way that if we describe instructors, it's still not there. But if we show create table instructors, now that constraint is named tenure positive instead of the default name that SQL provides. So if we insert, let me just check the name of the instructors in there already. So we are going to insert into instructors, first name, last name, my mistake, tenure, values, Bill Williams, and we're going to try that -5 again. And now, instead of the weird name it gave us before, it gave us a much more meaningful name. Tenure positive is violated. So of course it didn't get entered, and we know that the problem was tenure wasn't negative, or it was negative, wasn't positive. And those are constraints. And now we're going to move on to joins. In the joins, we're going to deal with the instructors table that we've been playing with, and we're going to add in the course table and make some joins between this. So as we mentioned before, in their normalized form, all of this data is separate because we don't want to clutter things down. But when we return the data, you don't want to return data in multiple tables. You need to put this data together in some meaningful way so that people can use it, usually a web app or some sort of app on the other end that is going to deal with this information. You want to return the non-normalized table, known as a record set, or result set, sorry, all in one table. So we are just going to go, I'm just going to make sure that we're going to go to here, and we will reset the table, just make sure everything's the same. And we are going to go, and we're going to talk about, the first we're going to talk about is inner join. And I've got a little caveat here that it's the old syntax. So we can select, when we did our select statements in the past, we've always included just one table. We can actually select from two tables. And when we select from two tables, because both tables have a UID column, we're going to add the syntax, which is table dot column, to specify what column we're talking about. We didn't have to do that with courses instructor UID because there's only one in there, and you'll see why I named it that way. So let's have a look-see. We are going to go select star from instructors, comma courses, and do nothing to it. Actually, what I'm going to do is I am going to get rid of the tenure. This is just to make it a bit more readable, not for any reason beyond that. I want this all to show up on one. There we go, all on one screen. And what we've got here is you're going to recognize that we have every instructor that we have. And all of these instructors, they're all the instructors from the instructor table, but they're merged with the first row from the courses table. And then you have every instructor from the instructor table merged with every course, except the second record from the course table, and so on and so forth. We have multiple UID columns. This UID represents the instructor. This represents the course. And of course, the columns from the instructor table are first because we put them first, and the courses table are second. If we reverse that, you would get courses first and instructors second, right? Now, this is known as a cross join or a Cartesian join, and it is fundamentally useless. It's just good for demonstration to show you that we can join two tables, every record on two tables together. So what we want to do is we're going to add a where clause. And our where clause previously and now restricts the columns we're going to select. So we're going to select instructors.uid. So select all the rows from that cross join that match courses.instructor_UID. And this makes a lot more sense. So now we've only got ones where the instructor is paired with a course that they're instructing. And that's what this rule is telling us. Instructor UID, which is this here, paired with courses instructor UID there. Oh, that's the course UID. I got courses instructors backwards. It's the same thing. I'm just used to looking at it this way. So there's UID. Now, of course, we've got a problem. There's a lot of information going on here. There's a lot of duplicated column names. So what we're going to do is we are going to change this star. We're just going to select the stuff we want. So we got instructors.uid we care about. First name. We're just going to put in the last name just to limit it. Last name. And then we can add courses. Now, if you want to, you could go courses.uid, courses.name, and so on and so forth, or you can go courses.star to include all columns from the courses table. So there's UID, last name. Of course, we've got a UID repeat in the courses. So what we can do is we're going to add another keyword in here called as. And as kind of renames stuff. So instructor UID is going to be renamed as instructor ID. And then it's much more readable, right? So we know that UID is still the class UID. Do we care about that? Maybe. And the instructor UID. So that matches up here, instructor UID, instructor ID, and they match up. Now, I pointed out when we started this that there are certain instructors that don't have courses. And that is number 6, Patricia Brown, and I do believe number 2, Michael Bauer, and they're not going to show up in here. So any instructors that don't have courses aren't going to show up. And likewise, any courses that don't have instructors, because it's null value, also won't show up. And this is what we would call our inner join. And the inner join includes everything where there's a match between the two tables. But if there's not a match in this table, the left-hand table to the right-hand table, it's not included, right? So they have to have a value on your where clause that matches. Now, it's not the proper syntax with using the select. What you should use is select join. And this is the proper form for it. Although it's identical, it's considered the new syntax and more proper. Now, if we selected this here and we exclude the where clause, it still runs. But we want to do the same thing. So we're going to select star from instructors. Let me capitalize the keywords here. Instructors join, and inner join is just join courses. If we exclude, that is your Cartesian. We use the on clause to tell us where instructor.uid is equal to instructor underscore UID, which of course is from the courses table. Instructors.uid, and there we go. And that's your proper. And it's exactly the same, except that it's more easy to read. You know that it's a join going on. And you can do some other more advanced stuff. So you want to go, we do the same thing. We go instructor.uid. If we want just a list of everyone that is as UID. Instructors, I always forget that S. So there you go. And last name and so forth, right? If you want that, you want email. So what's going on here is exactly the same as the double select, except that we're doing an inner join that doesn't include null values or doesn't include missing matches, right? If we want to include missing matches, we're going to start talking about the left join. Now, whereas the join we used before is actually the inner join, the left join means in the long form is the left outer join. And what it's going to do is everything in the left-hand table is going to be included by default, as well as everything that has a match in the right-hand table. So, but what will happen, well, let's talk about the syntax first, is select star from instructors. We're going to add the left in front of the join keyword, and everything else remains the same. So this is considered the left-hand table. It's considered the right-hand table. Everything from here will be included at least once. So let's take a look. Select star from instructors, join courses, where instructor.uid is equal to courses.instructor_UID. As usual, I forgot the S on instructors. So let's take a look. Oh, that's join. Huh. I'm like, where's my missing row? It's left join. So left outer join. Where did I forget? Oh, where clause. It's not a where clause when you're talking about join. It's an on clause. Now we've got everything correct. Let's take a look. We've got an extra row. So it's handy that I did this. You can see 1, 2, 3, 4, 6, 7, 8, 9 rows showed up there. 3, 4, 6, 7, 8, 9, 10, 11 rows showed up here. And what's here that wasn't in our outer join, in our inner join, was number Michael Bauer, number 2, and Patricia Brown, number 6. And the reason for that is they are not actually teaching any courses. So when there's a value, here that's not got a match on the right-hand side, was a match on the left-hand side that's not on the right-hand side, it will merge it with a null set. So there we have a null set of course values. Note, however, if we take a look at courses, semicolon, English 1500 here, course number 10 is not to be found in here because it's only including the left-hand side by default. If we want to include the right-hand side, instead, we use what you would think, right join. And what the right inner join does is it takes all the values from the right-hand table, merges it with all the values from the left-hand table on an on clause, so it includes all of those, but it will also include all of at least every row in the right-hand table at least once. And as you would guess, it is a right join is the syntax, is the right there. So let's take a look. So let's do the exact same thing. And we are going to change this single keyword, right join courses. And now, instead of the instructors that were missing courses before, the courses that are missing instructors are included now. If you think or you realize that if you just reverse this to left join and you reverse instructors and courses, what you will get, you will notice that that is exactly the same thing. And if we just take a look, the only thing that's being reversed, the same number of rows, same information. But of course, we put instructors on the left up here and instructors on the right down here. But it's all the exact same information down there. So that's just a left join is a mirror of the right join, and the right join is a mirror of the left join. The time you use whichever one you want, depending on what makes your code basically more readable. So that puts us down almost exactly at 1 o'clock. So if anybody would like to ask any questions,